Welcome to our tutorial on Python's data classes and nametuples. First, we'll introduce both concepts, explore their use cases, and then dive into the key features of each. After that, we'll compare them side by side to help you decide which one is right for your project. By the end of this session, you'll have a solid understanding of when to use data classes versus nametuples. Let's get started. We'll begin with an introduction to data classes and what problems they solve. Then, we'll look at some real-world scenarios where nametuples shine. Next up, we'll cover the essential features that make data classes so powerful, like auto-generated special methods and field annotations. Following that, we'll discuss the immutable nature of nametuples and how their fields are accessible directly. Finally, I'll walk you through a comparison to highlight key differences between these two constructs. By the end, you'll be well-equipped to choose the best fit for your Python projects. Welcome to our tutorial on what are data classes. These special classes were introduced in Python 3.7, and they're like a breath of fresh air for managing data. With data classes, you get the convenience of automatically generated and methods, just like with nametuples. But here's the kicker. Data classes are more flexible. You can add custom logic and define field attributes such as default values or even include validators to ensure your data is always in check. So if you're tired of manually writing these special methods every time, give data classes a try. They'll make your life easier. Welcome back to our Python tutorial series. Today, we're diving into nametuples. Introduced in Python version 2.6, these are lightweight, immutable data classes with named fields, basically a structured way to store simple data. Nametuples can't have custom methods or additional attributes added after they're defined. Think of them as read-only dictionaries where you know the exact structure up front. They're perfect for small datasets where maintaining immutability is key. For example, if you're working with coordinates or user information, nametuples can make your code more readable and easier to maintain. Welcome to our tutorial on Pythons. So let's dive into an example. First, we import the class from the module. We define a nametuple with fields for and now, creating a new person named Alice who is 30 years old is as simple as this line. To see the values, we print out and, which will output Alice and 30. Nametuples are great for creating lightweight, immutable data structures. In our next slide, we'll compare this to Python's built-in, so stay tuned. Welcome back, everyone. Today, we're diving into the key features of data classes in Python. Data classes are a fantastic way to create simple classes with automatic methods like __, init, __, and __, This means you don't have to manually define these methods. They're generated for you automatically, saving time and reducing errors. Plus, data classes support default values, which is perfect when some fields need to have initial values. You can even add validators to ensure your data integrity stays on point. Another big plus? Data classes make working with mutable data structures much more intuitive compared to nametuples. Nametuples are great for immutable data but can be tricky when you need to update values. So, if you're looking for a simpler and more flexible way to handle your data in Python, data classes might just be the tool for you. Let's get started. Welcome to our exploration of the feature in Python. Let's dive into an example. We're defining a class called, which uses the decorator from the module. Notice how we've defined two fields, which is required and which has a default value of 0. This means if you create an object without specifying an age, it will automatically be set to 0. Let's see this in action. We'll create an object with the name Alice and print it out. Observe how Python handles the output, neatly packing our data fields together. This is a stark contrast to using nametuples, where you'd have to manually define each field and type. Data classes make initializing and working with objects in your code more streamlined and less error-prone. Welcome to our tutorial on key features of nametuples. Let's dive in. First off, nametuples are immutable by default. This means once you create a nametuple instance, its fields can't be changed, ensuring data integrity and preventing accidental modifications. On the flip side, they're lightweight and fast because they don't come with the overhead associated with full classes or dictionaries, making them perfect for small datasets where immutability brings real benefits. For example, imagine storing a student's information like their name, age, and grade level. Using nametuples keeps your code clean and simple, while maintaining the consistency of these data points. Welcome to this tutorial on comparing data classes and nametuples in Python. Let's dive right in. Data classes are quite flexible. They allow you to define custom logic, making them perfect for complex objects where you might need to do something special when an object is created or updated. For example, if you're working with a customer class that needs to validate data on creation, a data class would be your go-to choice. On the other hand, nametuples are lightweight, immutable, and incredibly fast, especially useful for small datasets where immutability ensures consistency across operations. They're like tuples but with named fields, making them easier to work with than traditional tuples while still maintaining their speed. The key takeaway? Choose based on your project's specific needs. Data classes for more complex logic, or nametuples for simplicity and performance when handling small datasets. Welcome back to our tutorial on Python's data classes and nametuples. So, when you're working with objects in your code, sometimes you need something a bit more complex where the object might change over time or have some custom logic attached. That's where data classes come into play. They allow for mutable objects that can be tailored to fit specific needs, much like building a house from scratch. On the other hand, if you just need simple, read-only collections of data, think of them as pre-built houses. Nametuples are perfect. They're lightweight and immutable, making them ideal for situations where performance is key or when you want to ensure your data doesn't change unexpectedly. So, choose wisely depending on whether you're working with complex mutable objects or just need simple, unchangeable data structures.